Martinson. I'm president of the Taos Chapter of the Native Plant Society of New Mexico. We are one of 7 chapters in the state. Okay, Ben has been in Taos for about 20 years. Started out as a carpenter. He's still involved with trees, but in their original form and not processed. He's chair of the Taos Tree Board and a member of the New Mexico Urban Forest Council, and is also a certified arborist by the International Society of Arboriculture. Ben studied conservation biology at the University of New Mexico, and he's currently working on a master's degree in natural resources through Oregon State University with a focus on urban forestry. His master's project is on Siberian elms in New Mexico, and that's what he's here to talk to us about. So, Ben, thank you. Welcome.
Well, thank you all for coming. It's a pleasure to be here, speaking at the Native Plant Society about very clearly unnative species here. But I think that we're all aware of the problems and the conflicts we've had with Siberian elms. And so I don't really need to go into that too much. I'm also not going to talk about why we should promote the existence of Siberian elm in Mexico. I don't believe in that. I'm not studying Siberian elm because I love them. I'm studying them because it's really important to me to support natural ecosystems, or the best approximation we can get living in urban environments or lived-in environments. So there's some compromises to make. So this tree is here, and I think the best we can do is learn to live with it. We can eradicate the tree on smaller scales, but as far on a landscape scale, it's really quite beyond us to get rid of it completely. So what I'm proposing today is some solutions to work with the tree in our landscapes, and I just feel that that's really important. So we did a tree survey last summer in which the Siberian elm showed up as 30% of the tree canopy, and that is quite significant because you can see the problem that would happen if we were to remove every single tree all at once. We'd be really putting a hurting on the trees that give so many benefits in our lived-in communities. So we have to think about how we're going to approach this. I think you all know, we all have a very strong emotional reaction to this tree. When the tree is sending out its seed and the seedlings are coming up in our garden beds, I'm sure every one of us have cursed it to some extent, even though we know that it's a living species, it has a purpose, it has a home, it has a native environment. It's just not here in New Mexico. But for better or worse, it has made itself a home here. Siberian elm is only a little bit from Siberia, but this tree is well adapted to New Mexico. What I want to look at is why this tree, we can get clues from its native environment as to why it's doing well in New Mexico. And I think that that's the best way to learn how to manage it and to live with it, is to look at it in its native environment. Siberian elm exists on the Mongolian steppes, in the Gobi Desert, in northern China, in North Korea, and just a little bit in southern Siberia. So I don't know how clearly you can see this, but this line here is that Siberia is up here. So Mongolia is this section here. The Gobi Desert is right about here. And this is mostly China. So it's mostly in China. And North Korea, of course, is over here. So the tree is, that's its native habitat, those regions of the world. And that's where it does well, although even in its native habitat, it's not a tree that covers the landscape. It still lives in patchy sites like it does here. So the native habitat, well, just note in this photograph, that looks pretty familiar, doesn't it? but that is in the Gobi Desert. And you can see there's some telephone lines. So it's, you know, portions of the Gobi Desert where people live. But the native habitat is semi-arid. It's prone to temperature extremes, high winds. Soils are low to moderate fertility. And the trees tend to grow in sparse individuals along intermittent waterways and in clumpy groves in grasslands and steppes. It tends to prefer rockier soils. It will tolerate denser, packed, finely textured soils, but in general it does better in rocky soils because the roots can penetrate into the substrate to find water easier. It does not tolerate standing water, so it will not grow in a riverbed, but it will grow near a riverbed where it can access the water. So this tree I pulled out myself from Par Field. I watched the seeds come down from the nearby elm tree, and I said, uh-oh, last spring. And then it rained, and 4 months later, that's my Leatherman, so that's about 3 inches long. So that's 4 months of growth. This tree is, and I'm sure, my guess is that you're all familiar with this firsthand. Trying to pull them out, they're very difficult. This tree is a survivor. And its biology has a lot of clues to why. So it's very tolerant of extremes in weather. It's tolerant of drought, temperature extremes, high wind, poor soils. This is similar to the habitat characteristics. It's tolerant of disturbances, and it thrives in unmanaged habitat, which is part of the problem that we are seeing here. And I would also note that it's tolerant to Dutch elm disease, which is a big reason why it was introduced in the first place. This tree grows at a terrific rate with water. Without water, it will grow anyway, but just not quite as fast. It has a very high germination rate, has a very high seed dispersal rate. Although it's the amount of seed, they don't travel very far. They tend to stay within 100 meters of the parent tree, but with the winds blowing around, it could travel farther. But that's just what one study researched. The pollen does travel quite a bit farther. I'll get into that a little bit later. This tree is made to withstand low water. And it has various functions that it goes through to do this. A lot of desert plants, and you all could probably tell me more about this, but there's a typical reaction to shut down the stomata in the leaves in response to low water availability to reduce the transpiration so the tree can hold on to more of its water. This tree does not do that. It continues to transpire as much water as it can even when there's low water availability. And the reason that it does this is so that the moisture emitting from the leaves works to cool the leaves during high temperatures during the daytime. So this is just its strategy. It's not a conserver, it's a user. So it continues to use water. It has the ability to change the osmotic potential in the roots. So the cells actually change their the molecules that are in there to allow more water to come in. So it's very aggressive at getting water. When it adapts to low water conditions, the new growth will also create smaller xylem vessels to reduce cavitation. And cavitation is when air bubbles get in the vessels that are bringing the water from the roots up to the leaves in the transpiration process. So with those air bubbles in the tubes, it loses the turgor pressure to be able to pull the water up through the leaves. So in that case, the leaves end up dying. But this tree, when that happens, big sections of the tree will die back. but the tree will continue to live. And during extreme drought, the crown will almost completely die back, but the tree will not be dead. It will just continue in its growth on a more subdued form, a more compact form. And that's true, that shares characteristics with other desert plants that to save water, they're not growing to such a large form that requires so much water. So it has the ability to physically adapt its structure even to low water conditions. And I just want to add that these things about the tree, I mean, it makes me admire it from the point of view of this is a species that's figured out to exist, a way to exist in very extreme conditions. And so, as I said, it's resistant to Dutch elm disease. This tree hybridizes easily with other elm species, and that helps the colonization process. There's a case in Italy, in the Po River Valley in Italy. They did some research to see how Siberian elm is mixing with the native Ulmus minor, and they're finding that it's crossbreeding to the extent that they're concerned that Ulmus minor is going to lose its individual genetic characteristics. And it's a big concern because they want to preserve the native species, but it's not just overtaking territory, it's overtaking the species genetically. So that's pretty sneaky. It's also been shown to crossbreed with Ulmus rubra, which is a slippery elm in the United States, and it crossbreeds with Ulmus americana. And there has been a lot of hybridization experiments seeing if it is able to confer Dutch elm disease resistance to these other species, and there's some agreement and some disagreement that it's not totally convincing yet. So the genetics are passed not as much through seed dispersal, but a high pollination range. And one study showed pollen traveling 7 kilometers to pollinate another elm tree. And so that's really its way of colonizing new territory. It can spread its genetics over a pretty far reach. So you can imagine in territory like New Mexico, it's going to move fast on its own. So this photograph was taken at the recent Taos Land Trust property right adjacent to Vaca Park, and there's quite a bit of elm throughout that area, and right now there's a lot of talk on how exactly to deal with that. The elm, just like in its native habitat, it tends to grow in clumps of individuals, and what we're concerned about here is how it interacts with the native species or other species that are here. It tends to dominate the landscape, and that's not quite true in its native habitat, but here it's having even greater success, and you can see areas where, because of the existence of elm in a certain location, the native species are really being outcompeted, for light and for water resources, for soil resources. So it's really a big problem for our native habitats here in New Mexico. It establishes on disturbed sites. It loves to grow along fence lines, in places where the soil has just been disturbed, in cracks in sidewalks, against buildings. Everywhere where you don't want it, and that presents a real management challenge because we're not just cultivating trees we want. We have to work on cultivating trees that we don't want, or the locations that we don't want them. And there was one study that showed that there might be allelopathic effects, but I've only come across one study that came up with this, and the author said that she wasn't totally convinced by her research, but that it warrants further research into that idea. And so she did experiments with elm litter and how it affected germination of other species. But it's something interesting to consider. I hadn't really heard that about Siberian elm.
What is allelopathy?
It's when the tree chemically alters its environment to inhibit competitive growth. So, I mean, it's a pretty deep subject, and there's a lot of debate about that. But in native plant communities, the allelopathy can work in favor of plants that should belong in that community of organisms. But I didn't want to say that that's what it's doing, because the research is still out on that. Why is it here? It was originally brought in the 1860s. I haven't found any secure records of that, only just that that's when it started. In 1905, cuttings were brought to by J.G. Jack to the Arnold Arboretum, and they were experimented, being grown out. In 1908, Frank Nicholas Meyer brought more cuttings from the Temple of Pekin. And so that's where this photograph is taken, near Fengtai, Chile, China. And I have a personal theory that this very tree may be part of the genetics that existing here in New Mexico. When this tree was grown out by nurseries, people really saw it as an answer to a lot of problems. There was a lot of problems with erosion on farmland, problems with cityscapes needing shade. So they looked to this tree to solve some of those problems, and it was extensively planted in windbreaks in the upper Midwest and the Dakotas, and did quite well in those functions. It was planted as street trees. It was promoted by nurserymen. A quote here from Donald Leopold. Because of Siberian elm's fast growth and tolerance to almost any site, nurserymen raved about the species, and consequently, through their zealous promotion, were responsible for its immediate popularity and tremendous success. So this tree is here because we invited it. We asked it to solve problems in our community landscapes, and farms, along streets. And as the case with many non-native species, invasive species, I mean, they were brought here to solve a problem, but then in the meantime created many more. And and a lot of people wish that we could turn back the clock and not do it. So to answer your question, Sarah, in the back, yes, there's confusion between Siberian elm versus Chinese elm. And clearly there's no difference between the trees. I mean, there's a huge difference between the trees. The one on the left is Ulmus Pumila. That's what we're talking about today. Ulmus parvifolia is another species of Asian elm that is nearly as hardy as Siberian elm, not quite. When Siberian elm was originally introduced to this country, they called them all Chinese elms. And from the map, you can see why. It's more in China than anywhere. But the reason that they went to the name Siberian elm was to distinguish it from the slightly less hardy Ulmus parvifolia. And because they wanted to sell this tree as being able to withstand very cold winters, such as in the Dakotas or up north. So that's the confusion, because still today people call it Chinese elm, when around here, there's very few real Chinese elms in New Mexico. There are some, but in most cases people say Chinese elm and they mean Siberian elm. And I've often corrected people, but then I realized that it's also more complicated than that. It's not that they're calling it basically by the name that was originally introduced to them. So it's, I think, as native plant enthusiasts, you understand the importance of using Latin names as being more accurate to say that this characteristics belong to this species. So it's important to see the difference, and I'll get into a little bit more of that. So yes, Siberian elm is what we want, but it's actually Chinese elm. So it's here. It's very widely distributed across the U.S., across North America. I just came across some articles, I haven't really gone into them, showing distribution in South America. And it's also in Europe. It's been noted as possibly the most introduced tree species in North America, the most planted tree species. It doesn't present the problems everywhere that it presents here. It's listed, well, I say it there, it's listed on invasive species for 25 states, but the invasive characteristics are most pronounced in the Southwest. And we're looking at Colorado, Texas, Arizona, Utah. I haven't heard about California, but I wouldn't be surprised. In New Mexico, it's listed as a Class C noxious weed. And that means basically that it's everywhere and it's a problem. So here it is. It was brought to New Mexico, and we had a governor, Governor Tingley, very well-known, pretty controversial. He was kind of a rebel governor. He just kind of had his own idea about things, but he did a lot of really good things for New Mexico. I can't say that introducing Siberian Elm was one of those things, but he was really into it. He saw it as a solution for urban areas, for communities, for towns, for plazas. And in the 30s, he offered seedlings for free, so as long as people said, yeah, I'll plant it. And so he was partially responsible for a lot of the distribution in New Mexico. There's an arborist down in Albuquerque named Brian Sewer, who I believe he's now in his 60s. His father talked about the introduction to Albuquerque of these elm trees, and what a good thing it was, because Albuquerque, as you know, gets quite hot, and there's not really trees that can create the kind of cooling canopy that people want to see in urban areas. Cottonwoods usually need more water than is available, so you wouldn't really plant them on the street. They're good along the streams. So Siberian elm really created a canopy for streets, and so it really served an important function. And so the reasons that it was brought really made sense at the time. But obviously not foresight necessary to see that it was going to become a management problem. These trees are in Toronto, and I was reading in Toronto they actually treat Siberian elm like hedges. They prune them like hedges, and they actually really love them as hedges. They're everywhere in Toronto, but they don't let them normally grow into trees like this. This was a hedge gone wrong. And I've even seen a photograph of a pruning of a hedge into kind of an abstract dinosaur shape. And so they say, well, you can do anything to them. You can prune them down to the ground and they just come right back. And so they make a great hedge, as long as you manage it. So I don't think most people really consider it here. I've seen it on occasion. Sometimes they sneak into other hedges. But they're not a great street tree. They grow big, they grow fast, but they have brittle limbs, and they're not structurally put together very well. They tend towards codominance. So when you have two limbs that are growing side by side, the same size, it creates a weak joint between the two. That is it's just a weak structure that will break apart in storms. So that's really a problem with elms. And if you don't address that, then it's going to, it can become a hazard. And their habit of dying back under low water creates hazardous limbs that may just fall down, blow apart in the wind. I mean, they're just brittle, fall apart trees. I mean, arborists really dislike them, and I've worked a lot with them. I mean, I know from personal experience. They have an aggressive seeding habit, as you all know, and in Albuquerque it's morbidly known as tingly snow. And as we already talked about, big problem is that they crowd out other species. But there are some solutions. One is to try and work with the habits of this tree. There's a guy I found it in an old Native Plant Society newsletter, who called them the, let's see. Okay, Donald Hines in 2010. He was the Native Plant Society of New Mexico representative to the State Noxious Weed Advisory Committee, and he called it the bad boy of the elm family, that like all bad boys must be strictly controlled. So, you know, and it's an interesting article, I mean, written by one of your own, and, you know, he really had a lot of good discussion about the role of the elm and how to manage it in New Mexico. You know, a lot of similar things to what I'm saying today. So to care for this tree, as you can see in this photograph, this isn't New Mexico, but I mean, that's a tree that's serving a function, you know, for somebody's house. They can be pruned by reducing codominance. You have to, the management has to be active. Eradicating seedlings as soon as you see them. And also irrigation is an important note. You might think, well, this is a worthless tree, I'm not going to water it. I'm not going to give it any of my precious water. And, you know, that's something to consider. But along with choosing the spot that you want this tree to grow, you can also choose to irrigate it. If you do irrigate it, it's going to develop a better structure and not going to have the dangerous dieback that I talked about. And I think a long-term option is to consider replacing these trees with more suitable species. But again, we don't want to do it all at once. We want to think about staging this in such a way that we're not going to lose all of our tree canopy all at once. We want to do it thoughtfully and carefully and long-term. I mean, like thinking like, okay, this is a 20-year plan for Taos and how we're going to remove Siberian elm from the tree canopy. And part of initiating that process is mapping the presence. And as I said, we did a survey last summer where we got a good handle on how many trees, and I mean, they're difficult to map because they grow in these clusters and it's hard to go and measure every one, so you kind of group them together, and that's a trick in itself. But there's an effort currently now with New Mexico State Forestry where they're trying to map the elm populations throughout the state. So it's not just Taos that's looking at this, it is a statewide effort. And there's funds to do a program of mapping and coming up with management plans to help deal with this tree. So they're trying to look at plazas and public places where these elms are really strong, and developing management plans for those areas. And this is a 3-year project, I believe. So I mean, but they're initiating this, and you know, you'll probably hear more information as this moves along. So then, in the idea of strategic replacement and removal, we have to think about what are we going to replace it with. I don't really think it's a good option to just remove them all at once, as I've said. And there are certain things that we can replace it with. If a native species fulfills the function that we want, then I would absolutely advocate for that. But again, there's not very many native species that are going to provide a tree canopy. And again, cottonwoods are a possibility in certain cases. There's also box elders. We've had some success planting them. They're also native. If anyone from your group has suggestions on how to address this, I mean, we're all open ears. I mean, we're looking for solutions. Ulmus parvifolia, which I mentioned before, is the real Chinese elm. That is an option. It'll do well enough in Taos. It's not going to probably excel as much as the Siberian elm. There's also, through the Morton Arboretum, there's also Asian hybrids, and so, which are also Dutch elm resistant. So this is Ulmus japonica, Wilsononia Morton. So this was put together in the Morton Arboretum. And this is a very similar tree to Siberian Elm. It grows to a similar size. It's non-invasive. It seeds in the fall, so it doesn't have the same seeding habit. As far as our experience and the literature says, it's not suckering. It's probably similar in its resistance to mortality, but if you choose to plant a tree like that, you'll probably want to take care of it. So that is an option. And we're looking for more options. So some of you may have been waiting for. So this is this photograph. This is a client that described to me this process of trying to kill this tree, and he cut it down and it resprouts, and he cuts it again and he resprouts. He goes every year and cuts off the new sprouts, and this is 5 or 6 years later. It's still resprouting. This tree, it's genetically wired to just continue growing. I mean, cutting the tree down to the ground is nothing for the tree. It's not hurting it at all. It probably likes it. So this is really a problem. So there are some solutions. None of them are great. The first one is persistence. I suspect that if he keeps cutting these sprouts, within maybe 10 years, who knows, it may, it's growing by the side of a road, it's getting water, drainage off the road. You may be able to take care of it. So persistence might be an option. And certainly, it's obvious, but the sooner you get to it, the better. If you can pull them out when they're young, that's the best. You can excavate the root system on a smaller tree, that's not so bad. On a big tree like this size, it would take heavy machinery to do that. And and that's not always an option. There are some techniques documented. Girdling works. It just takes time. And so girdling is removing a 3-inch strip of bark in a circumference around the base of the tree. And you have to do this carefully. You only want to remove the bark and the phloem layer. You don't want to cut into the xylem. Because as soon as you cut into the xylem, or the woody interior of the tree, you're going to trigger a growth response that you can't really turn that back. I mean, it just kind of keeps going. So by girdling the tree, you can kill the top of the tree. And by removing that strip of bark, leaving the top of the tree just sitting there, in a couple of years the top will die back, and then you can remove the rest of the tree. And this isn't always a great idea, because if you have a tree in your yard or whatever, you don't want to just sit there and watch a tree die for 2 years. I mean, no matter what it is, it's just sad to see. So that option might work, for example, on the Taos Land Trust property, where there's nobody interacting with the trees on a daily basis. And, so we're actually planning on doing some experiments there on this technique. Then there's also herbicide, which I don't know how you all feel about that, but I'm personally pretty scared of it. But it does work, and along with girdling, it might be a much quicker solution. And so glyphosate or Roundup can be used in combination with girdling to kill the tree faster. And you can also use some of these herbicides on the young seedlings, but again, the impacts on the soils, on other species. I mean, there's a lot of questions about it for me personally. So I think you would have to judge that for yourselves. As far as killing the trees, those are the options as I know them. There's a nice field guide for managing Siberian elm in the Southwest, put out by the USDA. If you just Google this, you'll find it. But they list all of these eradication techniques in greater detail. So if you really want to know, there are resources out there. Also, the Native Plant Society newsletter from 2010 that I mentioned also describes some of these techniques. So the information is out there. And that wraps up what I specifically wanted to tell you.
Are there any native elm trees in America?
In America? Yes, American elm,
Yeah.
Ulmus americana is native. Ulmus rubra is native, which is slippery elm, which I believe grows in the northeast. Is that right? So yeah, there are native elms, and they've done studies on the hybridization with Ulmus rubra, and seen that it is occurring. But studying these guys is difficult. I mean, they're just so. Because like studying anything that has a landscape ecology kind of effect, the scale is huge.
But they never promoted these American elms,
Well,
Siberian elms.
they did. I mean, the American elms are susceptible to Dutch elm disease.
Okay, that's.
And they are the iconic elm, beloved elm in the U.S. Streets were lined with these.
Those are the ones that went up and kind of branched out.
Yeah, they're really big,
Yeah,
huge, beautiful trees, well loved. And when Dutch elm disease came along and removed them from many of these streets, I mean, it was really, really sad for many communities. And the lesson there is, when you're thinking about planting trees, go for diversity. You don't plant all of one species. And I mean, I understand that we're largely talking about areas that people live in communities, and a lot of what you all are interested in, I presume, is plants in their native environments. And but there is a correlation there, because as we affect more and more our native environments around us, we have to deal with the same kinds of issues. And we're also seeing Siberian elm showing up in, not lived in environments, but in native environments. Yes?
This may fall in the realm of suburban myth, but I've heard that you can drive a copper spike and just about any tree and kill it. The other thing I've heard is if you cut off an elm tree at ground level, crosshatch it, and put a Clorox in there, it'll die back. Has anybody heard that?
I've heard the copper spike theory. I haven't seen it for sure. I haven't tried it myself. I haven't, I'm not convinced until I actually see it happening. As far as the Clorox, I haven't tried that one myself. I have used agricultural vinegar, which is just high-strength vinegar, 30%. And we've tried drilling holes, which would have the same effect. And then, so again, if you're going to use herbicide, you have to do it immediately after you cut it, because the response is very fast. And so and you also want to do it in the fall, because that's when the vascular system is pulling it down into the root system. But we've tried drilling holes and using the vinegar, and it didn't work. But I think my next approach would be to girdle it and use the vinegar like that, because I think putting it in the xylem, that's not, or in the woody part of the tree is not really where you want to get it. You want to get it in the cambium layer, which is just beneath the bark. So she asked, how do you get the vinegar into the place where you girdled it? There's various applicators, like even a paintbrush was recommended. You just want to, if you imagine that right beneath the bark, there's all these tubes going both up and down, and you want to get the vinegar into that vascular system in the fall, and it should suck. You can really put a fair amount of it in there, and you want to do it right after you girdle it. Is that, so I mean, you can use a spray bottle, but I think if I were doing it, I'd probably just use a paintbrush.
Or a turkey baster, you can actually
Right,
squeeze
yeah.
a turkey.
Yep. Yes,
What's the width of your girdle?
3 inches.
Oh, good.
Yeah. Yeah. Yes.
Does it matter if that girdling is done in the spring or fall? Is that all that stuff for?
It's
for
most
rain?
effective in the fall, because that's when the vascular system is actively pulling it down into the root system.
And is it obvious where the tissue becomes woody? Is that an
Yeah, if you-
obvious kind of a place?
It's pretty obvious. It's a real change. I mean, the woody tissue is hard, so that because it's the vascular system is right beneath the bark, and it's just really a few cells wide. So you want to just fully remove that section of bark right down to where the wood gets hard.
What about tree stumps that just keep on sprouting? What can you do about those?
Well, if you have enough, if you have a backhoe, you can pull it out. You can try and recut it, and then use a paintbrush with vinegar or herbicide, whatever you choose, and and focus on the area right at the edge of the bark, and just really flood that area with whatever you're using, because that's where it's going to do the work. Yes.
So for the Taos Plaza, when you have a tree that's performing a really significant function, so currently in the urban infrastructure, there's no real good replacements at this point. If you to create a plan and say, well, if we were to slowly evolve them out, remove them, what are we going to replace them with? How long is it going to take to give us the canopy, etc.? It's diabolical.
It's a long-term process. Yeah.
Yeah.
And I forgot to mention this, but this day that I took this photograph on the Taos Plaza, I wanted to see. I was just photographing elms, just because for stuff like this. So I counted all the trees on the plaza. There's 12 mature trees, or large-sized trees. 6 of them are Siberian elms. There's a couple locusts, a couple cottonwoods,
Fir trees.
spruce, right? But half of them are elms. And so, you can see, to think about how to address, just in this small scale, these 6 trees, if we remove those all at once, the plaza would become an uncomfortable place to sit.
Are they causing a problem?
I mean, they seed.
In
They
pavement,
have to
maybe
be-
they're on, they land on, but the seeds land on pavement.
Right. Well, they germinate, but the town crews take care of it to some extent. These trees need to be pruned. I'd say at the minimum every 5 years. I've pruned a few of them at this point. It's not easy to do because in the plaza there's a lot of people around and traffic. So they have to be maintained, and I think that's kind of the key to this. If we're going to live with them, we have to be very proactive in our maintenance.
Thank you, Ben. I'm sure we'll be able to answer some more questions if you have them, but we appreciate you.